Welcome to day 3 of our Unit 1 exponential function unit. I hope things have been going okay for you so far. Remember, if you have questions, please make sure that you're asking for clarification during class. In today's lesson, we're going to look at rational exponent laws, and rational exponents are the ones that are written as fractions, as opposed to just plain integers. We're looking at our fraction exponents here. And what I have for our goal is that you're able to apply the exponent rules to questions that contain integer and rational exponents, and am able to rewrite rational exponents in radical form and vice versa. So we explored this topic back in 3M math, but it's likely that you may have forgotten. So here's a little investigation that I would like you to work through. You are totally able to use your calculator for this, so you can use your exponent button, and then just get your answers for each one of these calculations for part A and for part B, 1, 2, 3, 4, 5, and 6, and see if you can come up with a conclusion, a big idea. What do you think the big idea is in part A's the investigation part A, and what do you think the big idea is for investigation part B? And then you can continue playing the video, so put the video on pause while you're doing that, and then you can play the video and I'll quickly go through what the big ideas are for that. Okay, I have my answers filled into the chart, and I'm hoping that you've had a chance to look at what you think the big idea is between these 3 columns that we have here in part A. So the first column, with what we're doing here, all of these values ended up being perfect squares. Anything to an exponent of 2 is called a perfect square. All right, so all of those numbers are just the square of an original number, something to the exponent of 2. Number 2, I had a fraction exponent, so 1 to the 1/2 ended up being a 1. A 4, let me grab a different color. Here was 4 in number 1, so 4 to the 1/2 kind of worked backwards to be a 2. And then 9 to the 1/2, here was 9. 9 to the 1/2 worked backwards to be the 3. Okay, and then we have a 16 to the 1/2. Here was 16 as an answer, and we're working backwards to get the 4, and so on. So the third thing in column 3, what it looks like here, if I have a power of a power rule. The rule is I'm multiplying the exponents, so 2 times 1/2 just means that that's 2 over 1. That's going to equal 2 over 2, which is 1 whole. So I really have 1 to the exponent 1, which is equal to 1. Okay, similarly, 2 times 1/2 is still a 1, 2 to the exponent 1 is a 2. So the exponent 2 and the exponent 1/2 really kind of cancel each other out. They undo each other and leave you with just whatever the base was. This concludes that the exponent 1/2 is the opposite of the exponent of 2. Just like here, it was like working backwards. It's the opposite operation of the squaring. So the big idea here is that an exponent of 2 versus an exponent of 1/2, the half exponent is the opposite of squaring something, and the opposite of squaring something is the square root. So our big idea is that a to the exponent 1/2 would be equivalent to the square root of a. So the exponent of 1/2 is the opposite of the exponent of 2. Okay, I'll just type that in here. Okay, so what I've added in words is that the exponent of 1/2 is the opposite of the exponent of 2. In other words, the exponent of 1/2 is the same as the square root, because the square root is the opposite of exponent of 2. So that's what we have over here, and I just realized that my A almost looks like a 9, so I'm just going to fix that because I don't like misleading people. So there we are. A to the 1/2 is equal to the square root of A. Okay, moving on to part B. I'm working with exponents of 3 here. So I've calculated all of those. Those are cubes this time. It's not squares. We're cubing things. We have those answers. And then when I take the 1/3, 1 to the 1/3 work back to the 1. The 8 to the 1/3 matches with the 8 here, works back to the 2. So it looks like, again, we're undoing. So the exponent of 1/3 looks like it's the opposite of the exponent of 3. Likewise, 3 times 1/3, power of a power, you're multiplying those exponents together, you get 3 over 3, which is a 1. 3 divided by 3, which equals 1. So we have 1 to the exponent of 1, which is just 1. 2 to the exponent of 1, which is 2. 3 to the exponent of 1, which is 3, and so on. So the exponent 3 and the 1/3 are undoing each other. They're opposite operations. So the opposite of cubing a number would be cube rooting the number. So we know that a, base of a, to the exponent of 1/3 would be equivalent to doing the cube root. So a number times itself times. What number times itself 3 times equals a? That's what the exponent 1/3 is telling us to do. So again, I'll summarize that with typing. Now we could continue this kind of an investigation with exponents of 4, and then a 1/4, exponents of 5, and a 1/5, and so on. But we're going to find that just in general, more generally, oops, undo, there we go, good. More generally, we could write this as, sorry, trying to pick my right color here. Generally, we could write that as a to the exponent of 1 over n. So I don't know what that value of n is. It's any integer value. Actually, we'll make it any not whole number, natural number. So like 1, 2, 3, 4, 5, and so on. That's going to be equivalent to the nth root of the base. Okay, the exponent of 1 over n will be the opposite of the exponent of n. In other words, the exponent of 1 over n is the same as the nth root, is what we call that. And I'll just type that in here too. And I just realized I had a typo in my writing on those other two. I'll just underline where my typo was right here. I had the word and, I think, instead of an. Autocorrect, I guess, switch that, but I've changed them both now. So if you noticed that, good for you. If you didn't and just copied it blindly, you might want to fix that up. The other thing we know from previous years is that if you have something other than a 1 on the top of that, let's say you had m over n, so those are just whole numbers, no decimals or anything like that, we're still going to have the nth root happening, but that could actually be broken into a to the 1 over n all to the exponent of m. So I'm really using my power law backwards, my power exponent rule backwards, and breaking the m over n into a 1 over n to the exponent of m. So what that allows me to do now is the exponent rule we had just talked about, that would be the nth root of a all to the exponent of m. So if your number on top is not a 1, it's no biggie. No biggie. You're still going to do the nth root of the base, but then that answer gets the exponent of m. Another way that you could write that is that that is equivalent to doing the nth root of a to the exponent of m. So that m could go with the a under the root sign. So that works as well. Either way, you should get the same answer. So hopefully that makes sense. What I have next for you to work on is just expressing some powers in their radical form. So you can try those on your own first if you would like. Likewise, the next example after that is rewriting radical into their exponential form. So you can try those, and then I have another video that you can use to check. And then there's a third page, the last page of the booklet for what I've given you so far. You can work on those without using a calculator and see how you get along. And then after that, there are some duotang questions.